Students, good morning to all of you and welcome you all for the second module video lecture. So today I'm going to discuss about the module 2 power transistor. So in this session I'm going to discuss about the following topics: introduction about the power transistor, classification of the power transistor, then I'll cover the power BJT, one of the power transistor. Dear students, in the previous classes, means in the previous semester, you studied the transistor, ordinary signal transistor is studied. I think you studied this transistors both in the basic electronics as well as in the analog electronic circuits in the third semester. Recall the signal transistor. What is a signal transistor? How many terminals are there? How many layers are there? How many junctions are there? Okay. See, ordinary transistor is a 3-terminal, 3-layered, either NPN or PNP transistor. NPN or PNP. Two junctions device. One is input junction called as emitter base junction. Another is collector base junction for the for the common the base configuration. Now we will concentrate on the power transistor. How the power transistor different from the ordinary signal transistor. Dear students, so the power transistor is similar to the ordinary signal transistor. The difference is that in the structure you are finding the difference between the ordinary signal transistor and the power transistor, and also in the applications. So ordinary transistor, which can be used as an amplifier, the ordinary transistor can be used as a switch, but here the power transistor, which can also be used as a switch, but the power handling capability of the power transistor is more compared to the ordinary signal transistor. So the ordinary signal transistor, which is not capable of handling the devices operating at high voltages, high currents and high power, but power transistor can withstand high voltage, high current and the high power. Means high power handling capability is none other than power transistor. So the power transistors that are the control turn on and the control turn off characteristics. These actually I told you in the first module how the devices are classified, how the power semiconductor devices are classified. Your power electronics which depends on the switching of the power semiconductor devices. So we have the different power semiconductor devices which can be classified as thyristors, diodes and the power transistors. So based upon the controllability also we can classify the devices. So power transistors are devices that are control turn on turn off characteristics. And these devices used as a switching devices. Switching device means the transistor should operate in the cutoff and the saturation region, resulting in low on-state voltage drop. Power transistors are turned on when a current signal is given to the base or the control terminal. In the power BJT or in the power transistors, we have different types BJT and FET. BJT is current control device, but FET or MOSFET is an voltage control device. Since BJT is a current control device, the BJT can be turned on when a current signal is given to the base or the control terminal. The transistor remains on as long as the control signal is present. Until the control signal is not removed, the transistor remains on. The switching speed of the modern transistor is much higher than that of thyristors, and are extensively used in DC to DC and DC to AC converters, which means choppers and the inverters. However, their voltage and current ratings are lower than those of the thyristors. Since the voltage and current ratings of the transistors, power transistors are less than thyristors, and therefore power transistors are used in low to medium power applications. Let us see the structure of the power transistor. I told you in the beginning, power transistor is different from the ordinary signal transistor with respect to the structure. See, the structure of the power transistor is quite different from the ordinary signal transistor. So here you are observing one layer. One layer is added to the power BJT or power transistor. So that is called as the N minus layer. You are observing N minus layer is added to the power BJT. So that region is called as a drift region. Okay, that region is called drift region. So this layer is present only in the power BJT. This is not present in the ordinary signal transistor. Keep this point in your mind. So this power BJT has a 4-layered structure of alternating P and N type doping, which is shown in the NPN transistor. In most of the power applications, the power transistor works in the common emitter configuration. See, the base is the input terminal here of the control terminal, collector is the output terminal, and emitter is the common between the input as well as output terminal. See, in the power transistors, NPN transistors are the most widely used transistors than the PNP transistors. The characteristics of the device is determined using the doping level in each of the layers and thickness of the layers. The thickness of the drift region, which determines the breakdown voltage of the power transistor. So one more. So you are observing in this power transistor, in the power transistor characteristics you are getting what is the difference between the characteristics of an ordinary signal transistor and the power transistor. I will tell you. So look here, next thing is that the steady state characteristics of the BJT. This is the steady state characteristics of the ordinary BJT. This can operate in the 3 regions of operations. One is cutoff region, one is the active region, one is the saturation region. Cutoff region is the region where both the junctions are reverse biased. Active region is the region where the emitter based junction, input junction is forward biased and output junction is reverse biased. But in the saturation region, both the input junction as well as output junctions are forward biased. If it acting as a switch, it can operate between cutoff and the saturation region. But this ordinary signal transistor can be used as an amplifier when it is operating in the common emitter configuration. The steady state characteristics of the BJT is different from the power BJT. Why means, I'll show you. See, in this slide you are observing the characteristics of the power BJT is quite different from the ordinary BJT, that you are observing the quasi-saturation region. So in the ordinary signal transistor you observed only the, the saturation region. But here you are observing both odd saturation region as well as a quasi-saturation region. And one more difference between the ordinary signal transistor and the power transistor is that secondary breakdown you are observing in the power BJT when compared to the the ordinary signal transistor. And primary breakdown also you are observing here. The primary breakdown is occurs due to the avalanche breakdown, and secondary breakdown occurs due to the thermal runaway due to high temperature and all. You got this? So this is about the power BJT. See, power BJT which operates in 4 regions: cutoff, active region, quasi-saturation region and hard saturation. The cutoff region is the area where base current is almost zero, is no collector current flows and transistor is off. See, the power transistor or power BJT is a current control device. Unless you apply the current, unless the current flows to the base, the output current will not flow from the collected to emitter. See, in the quasi and hot saturation region, the base drive is applied, the transistor is said to be on. If the base drive is applied, so in the quasi saturation or hot saturation region, the transistor is said to be on, hence collector current flows depending upon the load. The power BJT is never operated in the active region, though you are observing the active region in the characteristics. Power BJT is never operated in the active region, means it is not acting as an amplifier. The power semiconductor device is always acting as a switch. Therefore, power BJT also acting as a switch which is operating between the cutoff and saturation region. As I told you, primary breakdown you are observing in the characteristics which takes place because of the avalanche breakdown of the collector base junction. That is avalanche breakdown of the output junction. Larger power dissipation normally leads to the primary breakdown. And the secondary breakdown shown is due to the localized thermal runaway. So that's all about your power BJT. So in the next session, I'm going to explain about how the switching characteristics can be drawn in the power BJT. The switching characteristics which tells you exactly how the power BJT is turned on and turned off. Okay, thank you. Please see the next session. So where I am discussing about switching characteristics of the power BJT. Thank you.